Hi everyone, welcome to this episode of Keipert Labs. In the next this kind of mini series of 3 videos, we're going to be discussing Newton's laws of motion. And specifically in this video, we're going to go through the concept of his first law of motion. So in each of these videos, we're going to outline what it is, and kind of go through some situations where this law of motion has something to tell us, or something, some power of explanation in terms of what's going on. But so I'll just give you a quick little bit of an overview to start with. Okay, so Isaac Newton, thinking back into the 1600s, very famous scientist, developed lots of ideas about physics and about forces that we still use and still have relevance to us today. And so basically we can summarize them into 3 concepts. Inertia. His second law, we would say F equals m times a, and his third law is this idea of action and reaction. So we kind of summarize, these will make a bit more sense that once you're a bit more familiar with what this all means. Okay, so at this point, that's just a quick sort of overview. Okay, so the concept of inertia is what we're going to be looking at in this video. Okay, but so just to give you a little bit of a quick little bit of background. So we were thinking back to ancient Greek times. Okay, so you may have heard of a very famous ancient Greek philosopher, ancient Greece, named Aristotle. Okay, so Aristotle proposed the first laws of motion. Okay, or kind of they had the first things to say scientifically about why things moved. Now the problem is that Aristotle was an incredibly smart man and was a very the ancient Greeks didn't do science like we do. Okay, science was not about experimentation or observation. Science was about ideas. Science was about thought, experiments. Okay, the Greeks didn't do experiments. And so Aristotle, who was a very smart man and quite a celebrity of his day, he didn't actually test anything out. So what we'd call them kind of thought experiments, or kind of where you just kind of ran through what you expected to happen in your mind, instead of not actually in real life. Okay, and so his ideas of motion were very clever, very articulate, and also very wrong. Not just a little bit wrong, not just a couple of days out of the week kind of wrong, but totally wrong. And Newton was the first person to actually come along, about 2,000 years later, and to actually demonstrate that why Aristotle was wrong, and to propose an alternative that kind of made some sense. Okay, so that's where these laws kind of kick in. Okay, so the first, so I'm going to write up for you Newton's first law of motion. Okay, so here we have, so I'll read it through for you. So an object has the tendency to maintain its state of motion unless acted upon by an unbalanced force. So there's a couple of key ideas here that I just want to touch on here. Okay, the concept of maintaining a state of motion, and the concept of an unbalanced force. Okay, now I'm going to address the second one first, this concept of unbalanced forces, because we recognize that on objects, like you sitting in your chair today is a classic example. Okay, so you're sitting in a chair. Okay, this is totally you. Don't be offended by my rubbish likeness. There you go, you got a smiley face, that's happy. Okay, so you, sitting in your chair, have multiple forces acting on you at one time, but 2 main forces. Okay, the first force is gravity pulling you down towards the center of the Earth. Okay, so it's acting on you on the center of, I'll say this is the center of your mass, acting down towards the Earth. Okay, so this is our gravity. Okay, but then what happens is that you don't fall through to the center of the Earth at the moment. So there's obviously some force that's working against gravity to keep you up. Okay, and so what we would do, we'd say it's an arrow here, that's acting on you, and that we call this the normal force. Not normal because it's typical every day, but normal because it's acting perpendicular to the surface that you are on. Okay, so it's not acting out this way, it's acting up this way from the chair that's holding your weight. And we can recognize that if the chair all of a sudden was not able to hold your weight, that you would fall through to the floor. And then the floor would bear your weight, and you'd be rather sore and uncomfortable as a result. Okay, but this idea that you have two main forces acting on you right now, as you sit here listening to me. Okay, but that those two forces are balanced. Okay, that the normal force of the chair holding you up is exactly balancing the force of gravity that's pulling you down, which is why you're not moving. You're not falling to the floor, or you're not being pushed up into the air in some way. That these are balanced forces. Okay, now, if for some reason these forces were to become unbalanced, so say the chair had a crack in it, and you sat down, and it did not, it bore your weight for a moment, and then all of a sudden gave way. What happens is that, based on that then the forces become unbalanced, and all of a sudden you start to move. You move rather quickly towards the ground in an uncomfortable and surprising fashion. You crash through and then kind of crash land at the bottom here, because those forces go from to being unbalanced, and so your state of motion changes. Okay, so if that unbalanced force wasn't acting on you, you would stay in your state of motion. Okay, and so this kind of, I said the second thing first, and now I'll do the first thing second, because apparently that's the logical way to do things. So that state of motion, when we talk of you maintaining a state of motion, that could be being at rest, that is stationary, i.e. not moving, or that could also be at constant velocity. Okay, so you're moving, but your velocity is not changing. You're not speeding up, you're not slowing down, you are maintaining your state of motion. Okay, and so this concept, this idea of this tendency that we're talking about here, we give it a name, and we give it the name of inertia. Okay, this tendency for objects to do this. Now, it's really important to recognize that it is not a force. Inertia is not a force as such. It's a behavior, it's a property, it's a thing that objects do, and so that we can observe and that we can predict and that we can depend on, but it's not a force in and of itself. Okay, so an object has the tendency to maintain its state of motion, so to keep doing what it's doing, unless there's an unbalanced force that starts to act on it. Okay, or the forces that are on it become unbalanced for some reason. Okay, so classic example here. Okay, of where inertia has something to say, or gives us it gives us some insight. Okay, you in a car. Okay, so many of you are learning to drive. Okay, or at least you've been a passenger in a vehicle before, and so you and your vehicle are cruising along. All of a sudden, the car in front of you stops. Okay, bang. Okay, you crash into the back of this other car. Okay, and what happens is that you and your body keeps maintaining its state of motion. Okay, that you'll notice that if this sort of thing happens, that then your body gets pushed forward. Okay, or actually, really, even to be a bit more specific, that your body continues to do what it was already doing, but there's just the car around you happens to have stopped. Okay, but you can see that that's going to be a problem. Very quickly, you have a piece of glass right in front of your face that then, if you continue to maintain your state of motion, you're going to meet it in a very uncomfortable way. And so we have designed seatbelts, okay, which are designed to stop you or to provide an unbalanced force on you. So seatbelt provides an unbalanced force that acts on you to keep you in your chair or to keep you in the car, that is to stop you from going headfirst out through the windscreen. Okay, unfortunately, before they had invented seatbelts, that there were huge numbers of deaths on the roads from exactly that. Okay, around about the time of, say, like when my dad was a kid, there were, stacks more teenagers who died on the road than there were today because there were no seatbelts. So just about every car accident was fatal. Okay, and so the seatbelt provides an unbalanced force on you that changes your state of motion. So instead of keeping on moving forward, that you stop. Now it's uncomfortable, but it's better than dead. So there's that. Okay, and so you otherwise would maintain your state of motion unless acted upon by the unbalanced force of the seatbelt. Okay, so the seatbelt changes your state of motion. It provides an unbalanced force that keeps you in your seat, keeps you alive, ready to drive another day. Okay, so just to quickly recap, so Newton's first law is the tendency, that an object has the tendency to maintain its state of motion, which could be at rest, stationary, or could be at constant velocity, unless acted upon by an unbalanced force. Okay, in your notes now, what I want you to do is I want you to see if you can come up with one or two other situations where Newton's first law is acting on moving objects, or that helps us to explain why objects move the way they do. Alright, thanks very much for watching. Bye for now.